So the discovery of antibiotics has led to a significant expansion of the human lifespan, and this is, it stands among the most important medical developments this past century. But unfortunately, pathogens have evolved resistance to our current arsenal of drugs, and so we need to find new antibiotics in order to keep pace with this resistance. So what you're looking at here is how the majority of antibiotics drugs in the clinic have been discovered since the 1930s. You first collect samples from the environment, and then you generate a library of microbes, and you hope that one of these microbes produces the next antibiotic drug. Unfortunately, with this pipeline, we keep discovering the same compounds over and over again, so there's really a dire need to discover new antibiotics. And so over the past couple of years, my lab has really focused on making this pipeline a little bit more efficient and accessible, and we've implemented a number of innovations, whether it's a bioinformatics pipeline to streamline the way that we collect microbes from the environment, or we've even improved the way that we can screen for antibiotics from these collections. And even recently, we've gotten a high-throughput robot that allows us to collect and process tens of thousands of bacteria in a very short period. So this is a great little thing that we've got, but what's really cool is all these innovations can kind of fit within a biosafety cabinet, this like really confined space, and it's allowed us to test a theory that we've always had. We think middle school kids can do what we do, all right? So we partnered with the James Jordan Boys and Girls Club down the street to form Chicago Antibiotic Discovery Lab. So students are paired with postdoc and graduate student mentors, and they're gonna be here and trying to do nearly every step of this discovery process. And so what you're looking at here is one of the students. She's actually, it's her first time at a college at UIC. She's operating and programming a $200,000 robot. She collected the samples from the environment. She right now is deciding what her library is. She's picking the colonies from one plate to another, and this plate is going to be screened against deadly bacterial pathogens. And so it was this student in particular that decided to collect goose poop. It's her choice. It was her choice. And from this goose poop, she isolated a strain that eventually produced these cyclic lipopeptides. These are new compounds, and the class of molecules is known to have activity against diseases, so we're currently screening it against cancers, a couple different infectious pathogens, and even malaria. And in a couple of months, when we publish this, that student is going to be a co-author in middle school. Wait, I'm not done yet. Okay. But so every single week we're bringing these kids to the club, and we're meeting them there, and we're going through biology, chemistry, math, pharmacy, medicine, computer programming experiments, and we're connecting every single one of those with a different step in the antibiotic discovery pipeline. But not only that, we're connecting them with different careers in STEM so that hopefully we can inspire the next generation of biomedical scientists. Thank you.